Good afternoon. So today we are going to see the questions on Unit 1. these these questions, I can say we have blanks and we have to fill that blanks in the questions. So first we have stress is the ratio of. Now exact definition if I will say for stress, then we have a resistance upon area. This is our real definition. Now, if we have this option, then we have to tick a resistance upon area. If we do not have this option, then only you can go for force upon area. But if both options are there, that is resistance upon area as well as force upon area, then you have to tick a resistance upon area, because force upon area is applicable only for elastic bodies, not for other bodies. So that we have to keep in mind while going to tick the option. Then we have unit of stress. Now we know sigma, that is stress, equal to we have resistance, and that we can say that is equal to R by A. And then we can have R, that is in Newton, and then A we have in mm square. Now we have different units for this stress. This is Newton per mm square. Then we can have MPa, where we have M, this is for mega, which is 10 raised to 6. And then we have Pascal, so that is Newton per meter square. So 1 Pascal, I can say 1 Newton per meter square. So we can have then GPa also. So we have different options while we are going to consider. This is for your unit of stress. Then we can have that is stress in elastoplastic material. So stress in elastoplastic material, that is sigma is equal to R by A. Now this value of sigma in elastoplastic is always less than force upon area, because if you compare these three bodies, this is most important. So elastic, elastoplastic, and then plastic. And there we know, if I will talk about resistance, then elastic F is equal to R. Then in plastic, R is always less than F, and then plastic R is equal to 0. And therefore we will get sigma in this case equal to R by A equal to F by A. Here sigma is equal to R by A, and this is less than F by A, and in this sigma is always 0. So that we have to keep in mind. Strain is defined as, so we have strain, that is epsilon is change in deformation divided by original dimension. Change in dimension, I will say, upon original dimension. This strain may be, this is linear, you can say. If I will say lateral strain, then I have delta B by B, then or I have epsilon lateral, so I can have delta T by T. So all strain we are going to define as change in dimension. It may be along length, along width, or along thickness divided by original dimension, respectively length, width, and thickness. Unit of strain. Now you can see, if we will see any strain, then we have change in dimension upon original dimension. So unit of both, that is numerator and denominator, is the same. That is maybe meter per meter, maybe millimeter per millimeter, gets cancelled, and we have strain, that is unitless quantity. So we have to keep in mind this. Then 1 Pascal, 1 PA in dash dash Newton per mm square. So already I mentioned 1 Pascal, and Pascal we have 1 Newton per meter square. And then we can have this E as 1 Newton. Meter square we have to convert into millimeter square. So we have 1 Newton upon 10 raised to 6 millimeter square, and then we will get it as 10 raised to minus 6 Newton per millimeter square, and that is value of 1 Pascal. So 1 Pascal is 10 raised to minus 6 Newton per mm square. In hurry, we are going to write down it as 1, but 1 MPa is 1 Pascal. So that you have to keep in mind, because if you will write 1 megapascal, then you can see mega we have 10 raised to 6, mega we have 10 raised to 6, and pascal we have 10 raised to minus 6, and then this gets cancelled, and we will get this value that is equal to 1 Newton per mm square. So while writing values, be very careful. Hooke's law that we know, within stress is directly proportional to strain within elastic limit, and constant of proportionality is Young's modulus, which is known as E. So this is Hooke's law. So within elastic limit, stress is directly proportional to strain, and then constant of proportionality is E, which is Young's modulus or modulus of elasticity. The relation between shear modulus and Young's modulus is, now we have E is equal to 2g in bracket 1 plus mu. Now E we have Young's modulus or modulus of elasticity, G we have shear modulus or modulus of rigidity. So we should know all these names. So modulus of rigidity, and E we can have modulus of elasticity. So these modulus we should know. So elasticity, and then we can have this relationship. Then we can have ninth relation between bulk modulus and Young's modulus. So we have E is equal to 3k in bracket 1 minus 2 mu. Now here only we have changed. So this is, we have bulk modulus, bulk modulus, and then mu in both cases we have Poisson's ratio. So Poisson's ratio. So we are been with this. Then we have next relation between all moduli. Now you can derive this. So I can show you very fast. E is equal to 2g in bracket 1 plus mu, and E equal to 3k in bracket 1 minus 2 mu. Now from 1, if you calculate mu, then you will get it as E upon 2g minus 1. And if you will substitute this value in this equation, so in this equation, then you will get E equal to 3k in bracket 1 minus 2 into E upon 2g minus 1. So we should be, if we forgot in examination, then we should be in position to derive it fast. So 2 get cancelled. E by g minus 2 minus 1, so becomes plus 2. And then we will get it as 3k in bracket 3 minus E by g. And then from this, if you will solve this, then you have 9k minus 3k E upon g, that is E. Now if you will solve this again, then Eg that is equal to 9 kg minus 3 ke. We have taken LCM. And then if we will solve again this, then if we will take this on left side, then we have, we will take E common, then we can have this as 3k plus g. And from this we will get, that is value of E that is equal to 9 kg divided by 3k plus g. So likewise, we have to actually solve these values and we should be in position to check it. So this is your answer, that is relationship between three moduli which is independent of mu. Then the property of material to get drawn into thin wires is known as ductility. Ductility. Then we have the last question, the ratio of shear stress to shear strain is known as. Now here also tau we have shear stress directly proportional to. Now here you can have phi or here you can have q. Different symbols are used for shear strain, and then we have tau that is equal to g into phi, and shear stress to shear strain. So we have G that is equal to tau by phi. So E we have sigma by epsilon. So stress upon strain is modulus, and that we have for shear stress to shear strain. So this is first video which helps you to answer the MCQ questions. So thank you. We will stop here today here only. So thank you.